Uh, Hello student, welcome to Introduction to Data Structure. The course ID is IT 179 in the summer session. In this course, we'll learn about data structures. The data structure is very core topics or core course in computer science. If you want to stay in computer science and if you want to do a lot of work in industry and if you want to get a good job in industry, you must have good knowledge in data structures. So the industry people basically when they will hire you, they will try to understand that whether you have knowledge in data structure or not. So it's very important course. So my suggestion would be to you, try to focus on this course and try to learn as much as possible. So what is data structures? Data structure means that how to organize or how to store data. So if we want to compare the data structure in computer science with some important things in our real life, for examples, in this slide you are seeing that dictionary. So we know that dictionary keeps a lot of words. So the words are in organized way. So if you want to find something, if you want to look for any word from the dictionaries, probably you don't need a lot of time to find that. So this is because all the words in dictionaries are kept in an organized way so they can easily found. So the other picture you can see that map. So in this map, so we have a lot of data. Those data basically use some x coordinator and y coordinator. So they uh, use those informations to draw this map. So similarly, if you want to find any locations from the map, so you don't need to a lot of time. And this is also because of the way the good way of organizing data. So the last one is balance sheet. The account people who wants to keep a lot of informations and want to maintain some data related to business, they maintain some structures and it's called balance sheet. They basically keep all the accounts informations in the balance sheet. The balance sheet structure is very organized so anybody can understand what is the current asset, how much they already paid, and how much they earned. So those information can be easily found or easily organized in this balance sheet. So in the real life also we are keeping data in a organized way. We are storing data in an organized way. You can see that these are the real life data structures. The question is, do our computer use any data structures? Yes, I would say yes, because we know that our computer use a lot of data, so millions of data. So when a computer try to find out any data from its memory, so it's easily find those data from the memory. This is because the computer keeps all the data in an organized way so they can be easily found. So we what we have seen that whether in our real life or whether in our computer life, our computers all maintain some data structure to store and to organize the data. So, what is the definition of data structure? What we have seen, a data structure is a way to store and organize data in computers so that it can be used efficiently. So, this is the definitions. Now we'll see a lot of data structures in this course and the motive to learn those data structures, so how we can keep our data in an efficient way so we can uh, access them effectively or efficiently. So we'll learn so many data structures, those data structure organize those data. So when we learn data structures, we'll see several things. So we'll see mathematical and logical model of those data structures. It also called abstract data type. And then we'll see how to implement those data structures. We'll talk about what is mathematical and logical models or abstract data type. And also we'll talk about the implementation of those data structures. So what is abstract data type? So abstract data type is something that you have a data structures, you know how to use them, but you don't know what is the implementations inside of that. So if you compare with this television, these televisions, we probably we use this kind of televisions in our daily life. We know that how to turn on or turn off the televisions. We know how to receive signal using antenna, and we know how to adjust audio and video because they have some instructions how to do that. But what we don't know, what are the implementations inside the televisions. We don't know how a system getting signals from outside, how it does do some operation to turning off or turning off the television. So we don't know how they are giving audio, how they are giving video. Those are the implementation we don't know, and we don't need to know that. We just need to know that how to turn on off and how to get signals or how to adjust audio and video. So we don't know about anything implementations inside of that. These kind of things called abstract data types. We know the outside of the data structure, we know how to use them, but we don't know how they work. This is kind of a abstract data type examples. So if we talk about uh, a computer science component or data structures component, which is a abstract data type, we can talk about the list. What is list? A list is a data structure that keeps some data, and it keeps several data. So when we have a list, so we probably know how to use that list. For example, so we know how to store a given number of elements of any type, and how to read some elements by positions, and how to modify any element at any position of the list. So this is kind of how to use that list. Probably we don't know what is the implementation of the list. Probably we don't know how they modify that element at that positions. Probably we don't know what is the implementation of reading element by positions you for list. So but we know how to use those things. So this is kind of a uh, abstract data type examples. So abstract data type defines data and operations but no implementations. So abstract data type, so when we talk about the abstract data type, uh, we'll think about uh, what is the data and what are the operation that we have to handle these kind of data structures, but we don't need to know any implementations inside that. So list was the general idea. So it's the abstract data type, But if you go to some implementation of list, so we can talk about the arrays and linked list. You already have learned arrays so in your previous course 168. So arrays is a kind of a list. You know that arrays can keep several data so of same type, so it's kind of a list. So you know how to build an array, you know how to store data into an array, you know how to retrieve data, you know how to find data from arrays. So you have to implement those things in your code. That basically saying that you are implementing the concept of list. So list is a abstract data type concept that give you the model that what are the operations we must have in these data structures, and when we are going to implement probably we'll use arrays, and other one is linked list. The linked list is not common to you, probably you didn't learn about linked list yet. So we'll talk about the linked list in this course, and we'll see several exercise, and we'll see we'll do some assignments on linked list. So linked list is a very important data structure in this course. So these are the two implementation of abstract data type. So let's introduce linked list. So since linked list is a list, so that makes sense that linked list keeps several data, probably similar type or probably not similar type. We'll talk about that later. But the introduction says that a linked list keeps several data in the list. So in this slide, you are seeing that there are several nodes. So these each block called nodes. So this each block contains two different informations. One is the data. The left side part of the node contains data, and the right side part of the block contains some address of the next node. So these basically the right side information basically saying that what is the next node. So we'll talk about in details in this course, but yeah, so now we are trying to giving some introductions. So linked list is a kind of a list that can keep several data, and this is the structure of a linked list. A linked list has several nodes, and each node contains two information. One is data, and another one is address of the next node. So you can see that the last node uh, pointing to null. That means so the last node doesn't have doesn't have any information in the right side of part of the node, because there is no any node after that, so they don't need any address of the next node. So that's why this is null. There is no any other node after that. So this is another data structure called stack. Stack is also a list, so but it has some restrictions. So if we compare with our real life stack, so you can see that is a stack of pancake. So now the stack of pancake kept a lot of pancakes. So now if you want to keep or insert a new pancake onto the stack, probably you will keep on top of the stack. You are not keeping that pancake in between any pancakes, or you are not keeping at the bottom of the stack. Probably you'll keep that new pancake on top of the stack. Now, if you want to take out one pancake from the stack, then probably you will take out the top pancake from the stack. So you are not taking other than top of the pancake from the stack. This is because it's easy to handle. So you can keep a pancake on top of the stack. You can take out a pancake from the stack easily. So this is kind of a nature of the stack. So when you are going to insert anything, you will insert on top of that list. Or if you are taking out any information, any data from the stack, you will probably take out from the top of the stack. So that basically is saying that the last item that you inserted into the list, that should be you know uh, accessed, or that should be taken out from the stack first, because that's why it's called LIFO. LIFO, LIFO, LIFO. LIFO means least input, last insert first out, last in first out. So LIFO means last in first out. So the item that was inserted into the very last, that should be accessed, or that should be taken out at first, or before all other items. That's why it's called LIFO, last in fast out. So this is one kind of a list. It has a it has a different natures. So you are not inserting anywhere in the stack. You are basically inserting on top of the stack. And when you are going to deleting something, you are not deleting any other element from the stack, but you are deleting the top elements of the stack. So this is another data structure, how to organize data or how to access data from a list. Okay, this one is the last one. Another one is called queue. So queue is another kind of a list. It keeps several data. So you can see that there are a lot of people's standing in the queue. So we are trying to compare the queue concept with the real life queue concept. Now, so if you similar to the stack, it also has some special natures. For examples, if you want to insert a new member of the queue, probably you will insert that member at the back of the queue. So a new people will come, a new person will come, and he or she will join at the back of the queue. And if anybody want to you know if in the first person of the queue will be will be uh, mm, uh, so he will get access at first before all other persons. So that means, so when you are inserting something, when you are inserting something into the list, probably you will insert at the back of the queue. And when you are deleting from this list, you probably delete from the front of the queue. So this is a different natures. So you are not inserting anywhere in the queue, basically you are inserting at the back of the queue. And you are not deleting from anywhere of the queue, basically you are deleting from the front of the queue. So this is kind of called fast in fast out, FIFO. FIFO. Fast in fast out means the person who come first, he will be served first. That's why fast in fast out. So this person, the first person, came before all other person who are standing behind him. So that's why he will be served before all of them. So that's why it's called fast in fast out, FIFO. So this is another data structures we'll learn about in details in this course. What is queue? So this is the general concept, how to compare, how to relate the computer science concept to the real life. The next one is tree. So tree is another data structure for keeping data. So here you can see that there are several data which are linked to each other. So a tree has several concepts. We'll learn about tree in this course. So these are the circle components of the tree are called nodes, are and the arrows are called link. So we'll talk about this tree in details in this course. So tree is another data structure for keeping information. So I'm not going to discuss more details about tree now because it will be more complicated for you. So whenever we learn those things, linked list or whatever stack, queue, tree, or so on, we'll try to see about their logical view. We'll try to see what are the operations we need to perform. We need to use those data structures. We'll see about the cost of operations. What is cost of operations? The how much space and how much time we need to do some to perform some operations. For example, inserting any element to a linked list. So we'll try to find out what is the cost of doing these operations. What is the time? What are the time we need to insert an element to a linked list? If you want to delete something from a stack, then we need to find out what is the time we need to delete something from a stack. So cost basically saying that how much time and how much space you need to do some operations to maintain some data structures. So we'll talk about the cost of operations, cost of each operation of each data structures, and then we'll see implementation of each data structure, how we can implement those data structures. So let's talk about some basic data structures that you already have learned those things. So array is the most important data structure that you have learned in the previous course. It's a list. So you know that a array basically can keep several data of the same type. So for example, if you have integer array, that means that array can keep uh, several data of integers. So in order to find some data from the array, you probably need some index. So you give some index, and using that index you find that specific data from that array. So when we declare an array, that basically keep those informations, the data in the array are kept in memory. So memory is the location where a computer keep all the information. So since we are keeping data in an array, so eventually they are keeping those data in an array. So if you declare an array, so these are conceptual idea that how data are kept in the memory. So every memory location has some address similar to the array. Say for examples, you keep several data in an array and index are the locations. So without knowing index, without knowing locations, probably you cannot find data from the array. Similarly, a computer keep data in their memory, and every memory location has some address, and these are kind of index. So using this location address, computer find those data easily. So these are the memory locations, and these are the data that you kept in this array. So these array are these data are eventually kept in the memory location, and these are the corresponding memory location address. So computer can easily find those value using this memory location address. The second thing is the string. You already have learned string in your previous course. String is a kind of an array. The difference is that the last element of this array uh, keep null value. So for examples, if J contains stand rocks, so stand rocks is a string. So here in this array, so if you consider this is an array, that these each character is element of that array. So this is a, you can consider this is a array of chart type data. So this each characters are chart type informations, and they keep all chart type information in the same array. So you can consider a string is an array. So if you go to the internal concept of the array, so you can see that similarly to the array informations, string informations also are kept in a memory in the same way. So each chart type data is kept in a different locations. This one is the space, and the last one is a zero, is a null characters. So as I said that the difference between normal array and the string is that in a string in a string the last character is a null character. That basically saying that this is the termination of the string. If it doesn't have null character, then computer doesn't understand whether string is finished or not. This null character says that we are done with the string. So string is a similar to the array. So it's kind of a chart type array. So it gives several chart, and the internal concept is also similar to the array. Other data structure is a matrix. Matrix is a two-dimensional list, so you can consider rows and columns. So if you talk about the spreadsheet in the Excel, you can see that there are a lot of rows and columns. So you can consider them as a matrix, or if you consider the computer screens has several pixels. So these pixels are kept using some xy coordinator, so this is also a matrix. So this is the how matrix look like. You can see these are the rows, and these are the columns. So this is first column, second column, third column. So you can call a matrix as an arrays of arrays. So why is an arrays of arrays? So you can consider this one is an array, this one is an array, this one is an array, and whole thing is an arrays of array. So this one is a sub array. So as I said that this one is a sub array 1, this one is a sub array 2, and whole thing is an array of size 3. So matrix is kind of an arrays of array. So we need matrix when we try to uh, build some any graphics, any map, or any spreadsheet, any table. Probably you need some matrix. And matrix also, the data in the matrix also kept in the memory. In that way you can see that the information of subarray 0 will be kept first, then the second subarray, and the third, and finally we'll have the third subarray informations are kept in the memory locations. So similar to the array and string, the computer keep arrays of array or matrix informations in the memory in this way. So that this is the structures. So other data structures, probably you didn't heard about the structures. Structure basically came from different language. You'll learn about the Java, but the Java doesn't have the structures. But you can call, you will learn about the class. Class is a one kind of structures. So some language called struct, and Java called class. So we know that a class contains several operations. A class contains several data members. Class contains several methods, or class contains several data members. So this is a kind of a structure. That structure basically saying that it can keep several variable or several data members in the same structures. So if we stick with the struct concept, if we don't go to the class concept, so this one is the struct structures. A structures contain several variables. This is a one variable's account number, this is another variable balance variables, and the whole thing is called, struct account. So account is the name of this whole structures. So that means a data structure which can keep different type of information, then we might call them a structure or struct. So here account is a data structures that keep two different informations. One is account number, another one is balance. So structure is a another kind of data structure. So if you want to if you want to assign some informations to the account number, or if you want to assign some informations to the balance, probably you can use uh, in that way j dot account number. What is the j basically, you can write j basically is some variables of this type. So struct account is a type, so you can declare any variables using account type. Then j will have some member called account number, and j will have balance member. If you compare with the class, so for example, so you declare a class, we define a class, then use that class, we can create some objects. Then object have access to keep some informations, can have access to members of the class. Similarly, so if you consider structure is a definitions of any type similar to the class, then you can use that, you know type to create some variables similar to the we use class uh, to create some objects. So this is the way how we can create structure is another data structures. The another one is node. Node is a similar to the structures. The difference is that uh, the it has one variable that is a pointers. That pointer, what is pointer? Pointer basically contains address of other variable information. So pointer type variable doesn't contain a specific data. That I mean, it basically contains address of other variables. So this is a difference. Otherwise it's similar to the structure. You can see that struct node is the name, and it contains two members, variables I and pointer next. Variable I probably contains some integers, and pointer next, next is a variable name, it is a type, pointer type, and it contains address of next next variables or other variables. So if you go to the linked list that we have seen in previous in this slide, you can see that these each node contains two informations. So that means this is a kind of a structures. So it contains one integers, and other part contains address of other node, and that basically says that node, these are the node structures or node structure that can keep two different information. So now we are seeing that these node structures is basically used for creating some node for the linked list. We'll see those things, how to use node to create linked list. So this is all about, this is all about uh, basic data structures and other things. We'll go to the next slide now. So thank you.